Good morning, everyone, and welcome to today's webinar from Radiocrafts. My name is Omar, and I will be presenting today's webinar. I see that we have people still joining. Maybe those who already joined, you can introduce yourself in the chat window. You can also tell me if you can't hear me quite clear, if I need to change something. Please feel free to do so. Maybe we can wait another minute to allow for the other people to also join. Meanwhile, I would like to welcome you to today's webinar and thank you for taking the time to join us today. I hope you can hear me loud and clear, and I certainly hope that this webinar proves to be worthy of your time. See people joining, so maybe we can start slowly. So today's webinar is scheduled for around 30 minutes. We will, as usual, try to keep 10 to 15 minutes at the end to have some sort of a short Q&A session. Good morning, Hassan. Yeah, it's also very sunny here, I guess, since we are neighbors, so we have a good day today. I just wish that all winter was like that, but you know. Also, this webinar is being recorded and the video will be available on our website in case you want to rewatch it. Good morning, Magne. Good morning, Felipe. So, what do we have here in our agenda today? We will first start by briefly mentioning the importance and benefits of using smart irrigation systems. Then we will just touch very briefly on the solutions Radiocrafts provide in the 169 megahertz domain and what kind of problems and challenges they can solve. And then comes the fun part. We will discuss some of the common challenges in smart irrigation. Then we will see together if and how RIIM provides solutions to these challenges. All right, let's start. When I did a little research to prepare for this webinar, I found that recent studies show something a little scary. They show that approximately 33% of the world's population live in some kind of water shortage. Not only that, they also say that this percentage might increase to reach up to 50% in just 10 years. So one would think, okay, let's start saving water and stop wasting it. Well, guess where 70% of water consumption is? Yep, I heard you saying it. It's irrigation. So I guess that's the best introduction to speak about smart irrigation and why it's important. I guess it's quite obvious by now. Smart irrigation is the way we can ensure the best utilization of our water resources, which means least water consumption for faster and healthier crops. But as always, just because the idea is nice doesn't mean that it will be simple or easy. Smart irrigation networks face a number of challenges. Some of the most important of these challenges are, for example, integrating different kinds of sensors and valve control to a central control unit, or maybe even a cloud platform. We have also the reliability of point-to-point or star networks in tough environments, such as those encountered in an agricultural field. From our experience, any outdoors network in general is challenging. I mean, in agricultural fields, you usually have all sorts of birds, maybe other animals. Sometimes it's rainy, sometimes it's windy. So network reliability and availability surely becomes a challenge here. We have also something that's hard to achieve is having an easy way to set up and install the network, having the ability to have control and efficient downlink, and of course, keeping maintenance costs low. One of the ways which one can address the challenge of reliability is by simply using RF solutions which operate in the 169 megahertz band. As you probably know, operating in such low frequencies gives more signal propagation and stronger penetration through obstacles. Might those be just obstacles in the field or even the ground? Plus, it's not a commonly used band, so chances of noise from cellular and whatnot would be relatively lower. Of course, not in all countries you can use 169, maybe just in Europe, as much as I know. But for that, we have the 17 series solutions, and you can read more about those on our website. Okay, so now speaking about RIIM. What actually makes RIIM so suitable for smart irrigation? RIIM has a number of technical advances which seem to make the process of implementing smart irrigation networks a lot easier. The first of these is obviously the mesh structure of RIIM. Being a mesh, the failure of one node does not mean the end of the world in RIIM, as child nodes will usually find an alternative path to reach the border router, which is commonly referred to as self-healing networks. It's very common in mesh. Obviously, this addresses the challenge of reliability. And even if the border router itself can be regarded as a single point of failure, we actually have just published an application note about using more than one border router per network to eliminate that single point of failure. And in addition, also RIIM is self-forming, which means that no manual setup is needed, which again addresses the operational costs. Next feature is a pretty cool one, actually. It's called time synchronization. So what is time synchronization? It simply means that the border router sends an absolute time information signal to all nodes, which means that now all nodes will have an understanding of time with millisecond precision. How can that be used? Well, basically, this will allow the user to set up synchronous events and events which take place at certain times. Like now, all nodes will know what time is it. So, for example, the user can set up a program to start irrigation at 7 or at 10 or end it at a certain time, or to start irrigation with certain intensity at a time and a different intensity at another time. Next, we have battery-operated mesh routers. I know that we have spoken about this before, so I'll just mention it very briefly. In conventional RIIM, nodes can be either leaf nodes, mesh routers, or border router. The difference is that leaf nodes can go to sleep and only wake up at certain times. That's why they can't have child nodes. While on the other hand, mesh routers have to always be awake, as they might have child nodes, and children don't let you sleep. So makes sense even in mesh. So what happened is that with Dish, in our new release, we have a new version of mesh routers which can maintain their function as parent nodes while also being able to be operated by batteries and go to sleep at certain times. So what benefits does that bring? Well, quite a few actually. First, it allows for extended range for up to 28 hops. Range can be extended by just plugging in the batteries to the mesh router device and simply switching it on. And that's it. No setup, no manual configuration. You don't have to extend power cables and so on. Since it's battery powered, so no power cables needed, so it can be deployed anywhere and within minutes, which is basically very suitable for smart irrigation applications, as it's not common to have power cables in agricultural fields. We offer 3 settings for battery-operated mesh routers, one for maximum throughput, one for maximum power saving, and a middle solution which balances between the two. Please feel free to check more information about battery-operated mesh routers in application note 42. Another very important feature about RIIM is actually the range of RIIM high-power variant. Now, I know that high-power modules are not best powered with batteries, but I'm just here to tell you both what you can have. Then I guess it's up to you to choose whether the high power fits you more or battery-operated mesh routers fit you more. So the high power can transmit with up to 27 dBm, which is quite impressive. This extends the coverage of one RIIM node to more than 10 kilometers in line of sight conditions. And then if you couple that with the fact that you can have 28 hops with RIIM, and basically you will be able to cover the whole big city with just one big RIIM network. In addition, since Dish uses frequency hopping, this means that you can use RIIM high power in countries operating under FCC regulations and transmit with 500 milliwatt. And you can check application note number 34 for more details about the range of RIIM, including RIIM high power. Actually, my 2 favorite features about RIIM are first, the battery-operated mesh routers, which we just discussed. And second is this, Radiocrafts EC. EC is the interface that Radiocrafts has created to configure your RIIM modules with just a few lines of C code. With EC, it's, as they say, it's event-driven, which means that you can set events and the corresponding event handlers and set actions when these events happen. By good utilization of this, you can basically have central intelligence in each node by using C, by using the if conditions of C, for example. So this means that not all data has to travel to the gateway or the central processing unit to have intelligence. You can actually have some sort of intelligence in each node by itself. And this, of course, hugely reduces the network traffic as it does this decentralization of intelligence. And on our website, in the document library, you can check application note 29 for more details about EC. So in RIIM, we support 2 types of application layer messages. We have CoAP and UDP. As you probably already know, CoAP does implement acknowledgements, but UDP doesn't. But does this mean that UDP messages are less reliable? Not really, because in RIIM we have link layer acknowledgements, which mean it implements acknowledgements regardless of the application layer. This, of course, adds more security on the hop-to-hop basis, which is another thing that which is another separate thing than end-to-end security of the application layer. So this is like an extra layer of security in case you're using an application which does not support acknowledgements such as UDP, for instance. And plus, co-op acknowledgements are end-to-end, but here with link layer, it's between each hop. End-to-end IPv6 connectivity. RIIM was made to natively support cloud connections using IPv6, which means that it's future-proof, that in the future, when all networks become IPv6, then RIIM will be supporting that, will not need any upgrade. This, of course, means that you have end-to-end IP packets, which directly translates to more security. When each node has its own IPv6 address, then it means that you can address it anywhere, from anywhere, which is global addressing. And the firmware needed on a Linux host to connect a RIIM border router to that Linux host through SLIP, we provide also now this firmware. So the setup becomes very easy for the user. And if you want to know more about that, you can contact us on support or sales, or you can also check application note number 47 to learn more about how you can set up SLIP to connect your border router to a Linux host, which then is connected to the internet. Adaptive frequency agility. In very simple terms, this means that the network is agile in a sense that it avoids noisy channels. So the border router continuously tests and chooses the best channel hopping sequence, which is of course only used in TISH. And then the border router informs his child nodes with this hopping sequence. This obviously translates to higher reliability and less packet errors. OneHop Multicast. In a normal multicast condition, a message is broadcasted and then all nodes repeat that message, which has two sides. First, it ensures that all nodes receive the broadcasted message, but also maybe a node would receive it more than once, which will mean that the network will be flooded always with these broadcast messages. So with the OneHop multicast feature, you can choose that this message only travels from one node to its direct neighbor, and that's it. Which means less network flooding, which means that you have more bandwidth available for control signals and uplink signals and so on. So, precision control. What does that mean? But first, do we really need control in smart irrigation? Well, in some applications, yes, because not all smart irrigation setups operate on the basis of sending soil moisture sensor data up to the control unit, for example. Sometimes control commands are needed to control the function of the water sprinkles, either to control the amount of water or the direction or the duration and so on. So control is basically downlink, which means that an effective and efficient smart irrigation RF network must have some sort of symmetrical links to allow for both uplink and downlink. But also bear in mind that downlink is not only important for control, it is also used for over-the-air updates and configuration and so on. So precision control basically refers to how effectively and quickly the user can send control commands down his network. So an important question here is, how does RIIM rank in this aspect as compared to LoRa, for example? In battery-operated mesh routers, nodes can wake up every 1 to 5 seconds to receive downlink messages, whereas LoRa nodes can take up to 100 seconds. And even when using Class B in LoRaWAN, all the extra beacons and stuff, they eat up the duty cycle due to LoRa's very little data rate, which gives it more time on air to send the packet, which then eats most of the duty cycle. In addition, control is not the only area where RIIM shows better performance than LoRa. For example, when it comes to range, LoRa is known to show a steep degradation in link quality after about 3 kilometers. Whereas with RIIM, of course, you have the multi-hop structure and extra layers of security, so reliability becomes eventually much higher. So to wrap it up, we spoke very briefly about water scarcity and how smart irrigation is a must. But of course, smart irrigation networks are not always that easy. To add this reliability, you can use 169 megahertz solutions, which we also offer. But for the 868 band, we have RIIM, which is currently gaining strong traction in smart irrigation markets, especially in Southeast Asia. We have now big players in the smart irrigation market which are redesigning their products by using RIIM. This is due, I believe, that RIIM addresses much of the common main pain points of typical smart irrigation networks, such as range and battery-operated mesh devices. Symmetrical links, which allows for more downlinks, since this is a huge pain point when using LoRa. And of course, the higher data rate, which is again one of the limitations of LoRa, which makes it have much time on the air and then eats up all the duty cycle in just control segments. I guess finally I can tell you that to test RIIM, you can visit digikey.com or contact your nearest distributor to order a development kit. I think that wraps it up for me, and now please feel free to start writing your questions if you have any in the chat window. Thank you, Graham, and it was nice having you. Thank you for your time. Well, that's nice to hear, Flippy. Thank you. Thomas is asking a question about RC1740 Tiny Mesh. This is a process which is ongoing. Did I open my mic? Yeah, okay. This is a process which is ongoing right now. The discussion with the management is ongoing. We are not 100% sure about what will happen in the future, but what we are sure of is that we are not. We need their support, Tiny Mesh support, for to support our customers, and we are not getting that on the level that we hope for. So we are trying not to push it into the market, because then it causes us problems when we can't support our customers, and we don't like that. So for this reason, we try to push RIIM instead as a more than perfect substitute. But as a decision, we don't have one. at this moment, but we will make sure to inform everyone when we have a decision about ending 17 series, the RC17 series or not. Tom Allen, well, Tom, that's very nice to hear. Thanks a lot. If you need any assistance or have any questions during your assessment phase, please don't hesitate to contact us on support@radiocrafts.com. It's not natively supported, but we can see what we can do about that. Yeah, okay, to be clear and in very simple terms, it's not easy to implement as it's not natively supported. But of course, if it's the project is in the right size and things are showing are promising, then of course we can consider doing something special. But it's not just one line of code that we can tweak. So that's why we can't like do it for a 50 pieces project or 500 or 1,000 project. But it is doable, yes, under the certain circumstances, I can say. Hi, Jan. Yeah, don't worry. I have my colleague here, Nicholas. I think he will send the link to everyone. Yes. Nicholas, I know you can hear me. Please make sure to send Jan here the link to the webinar recording after we're done. It will just, Jan, it probably takes just a day or something, but it will be there. Yes, we will make sure to send it to you. Hassan is asking about FCC for RIIM. We are in the process. It has started since a long time, and it is ongoing. So yes, we will have RIIM FCC'd. When? I am not sure, but what I know is that the process started since some months, so it shouldn't be a long time. I see Thomas is asking about RIIM on the 400 band again. Well, I'm not sure. Do I not get your question, or is it? I'm not sure if you didn't get my answer, but I was saying that yes, it is doable. But for certain project sizes, because it's not easy for us. It's not like one line of code which we will change. It will be some long time of development. So it can be done, but it needs management approval and special project, and has to be of a specific size and so on. Thomas, if you got that, please can you just confirm that now you heard my answer? Okay, so it seems that we have covered all questions. So I guess that's it for us today. I wish you all a very pleasant day. Take care, stay safe, and we hope to see you again on our next webinar. Have a nice day and bye-bye.